up section 5.1, we have 2.5 pages remaining. Okay. Oh, and before I start the recording, remember the chapter 5 and 6 lecture notes are already published in Canvas. So take the time this weekend to print them all out so you have them ready to go as we go through the last two sections or last two chapters of our trig content. Okay, so let's start the recording.
Recording in progress.
This recording will cover the second half of section 5.1. Okay, so in 5.1, we've learned how to solve oblique triangles. Oblique triangles have 6 unknown values, 3 unknown angles, along with 3 unknown sides. If we're given, we'll go back up here. So if we're given angle, side, angle, 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 side, we use law of sines to solve. If we're given side, angle, side, or side, 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 we use law of cosines to solve. The special case is the side, side, angle, ambiguous case. And in the ambiguous case, we have to check to see which category it falls in. So let's take a look at our ambiguous case SSA. Let's go down. Okay, so for our ambiguous case, and students, if the audio isn't sharp, please let me know. You see, everyone is back. For the ambiguous case SSA, the given information can form no triangle, one triangle, or two triangles. In order to determine which category we're in, we have to do the 2 check steps. So the first check step, we compare side across from given angle with the other side. If side across from given angle is less than the other side given, then we move on to check step 2 and compare side across from given angle with the height. And the note card tells you to determine whether we're going to end up with no triangle, one triangle, or two triangles. Okay, so if after check step 1, we see side across from given angle is actually greater than or equal to other side given, we stop and say one triangle. So after completing either just check step 1 or check step 1 and 2, we will be able to determine the number of triangles, 0, 1, or 2. Okay. So we saw one example where we had no triangle. We saw an example with exactly one triangle. And then the third example, we had 2 triangles. 2 triangles because side across from given angle is less than other side given, but greater than the height, which means that we have 2 triangles that are formed. Okay, so I asked you to solve the triangles on your own. I saw that we were on track, except for we have to make sure that, so according to this drawing, gamma 1 is our obtuse angle and gamma 2 is the acute angle. Okay, so when we solve the triangles using law of sines, we have to get the pairing. The pairing that's given to us is beta and B. So we're given B and beta. Okay, so it means we're going to set up sine of beta over B is equal to, and we're given C, but we want to find gamma. So equal to sine of gamma 1 over C. When you set up your proportion using law of sines, we want to set it up so that we have 3 out of the 4 missing values. And from there, we can use our algebra skills and trig skills to solve for that 4th missing value. Okay. So let's actually, instead of calling this gamma 1, we're just going to call it gamma. And our C value is 5.9. Okay. So to solve for the unknown value, we need to set the diagonal products equal to each other. So we have 5.9 sine of 38 degrees is equal to 4.7 sine of gamma. So let's go ahead and isolate sine of gamma. When we're solving for the variable, we need to first isolate the trig function. Okay, then we could isolate the variable. So here, when we take inverse sine, this is going to be the acute angle, because remember that inverse sine will give us the angle measure between negative 90 degrees and 90 degrees. So we'll make note. Inverse sine is between negative 90 degrees and 90 degrees. Therefore, it's going to give us gamma 2, the acute angle. Okay. Okay, so gamma 2, the acute angle, we'll take it out to at least 5 places. 50.61066 degrees. That is gamma 2. Because we can see from our pictures, gamma 2 is the acute angle, gamma 1 is our obtuse angle. So students, in the chat, share how you get gamma 1. In the chat, go ahead and share how we would find gamma 1. Or, I mean, share your answer for gamma 1. Okay, let's see. Justin, are you back? Yes, so let me check, Justin, to make sure it went through.
It's still not going in. I don't know. Because I uploaded the other one and I can't upload this one now. I'm gonna have to send it to you in separate pages then.
Yeah, send
Okay.
me
But I
your.
can't, it won't let me upload it to Canvas anymore.
Oh yeah, you won't be able to upload it to Canvas. We already discussed.
Oh, that's what I've been trying to do. All right.
Go through email. Okay, and Justin, even if we're going through the lesson, please interrupt and let me know when that's submitted. Okay, so students are sharing that we're going to do 180 minus gamma 1. Oh, oops. There we go. That's correct. So it's actually 180 degrees minus the acute angle to get the obtuse angle. When you do inverse sine, it gives you the solution in quad 1. Then you do 180 degrees minus the solution in quad 1 to get your solution in quadrant 2. And the solution in quadrant 2 is the obtuse angle, which is gamma 1. Let me repeat that. When we use the inverse sine, it gave us the acute angle gamma 2 in quadrant 1. Then we do 180 degrees minus gamma 2 to get gamma 1, which is our obtuse angle in quadrant 2. So that would be 129.38934 degrees. Okay. Okay, so once we have two angles in any triangle, we can find the third angle by doing 180 degrees minus 38 degrees minus 129.38934 degrees. Because we know that all three angles in a triangle will sum up to 180 degrees. So our alpha 1 is going to be 12.61066 degrees. We do not want to round until we have a final answer. So we have gamma 1, we have alpha 1. Okay. Okay, let's hear from Stephanie. So Stephanie, we have gamma 1 and alpha 1. How do we find the missing variable, the last missing variable, A1?
We can set up a ratio of alpha 1 over A equal to sine of 38 over 4.7.
That's right. We have to use law of sines to solve. Okay. Okay, so let me shrink. And we'll just make note. Solve for A1 now using law of sines. Okay, so you'd set up sine of 38 degrees. So sine of beta over b is equal to sine of alpha over A1. Solve for A1. A1 should be 1.67. And we can round A1 to 2 places because that is a final answer. Okay, so we use law of sines to find gamma, and we have two gammas. We have gamma 1 and gamma 2. Gamma 1 is the obtuse angle, gamma 2 is the acute angle. Then once we have gamma, we can find alpha. Once we have alpha, we can find A. So in the first triangle, check your answers. Alpha 1 should be 12 point, did we round to 2 places? Yes, 12.61 degrees. Gamma 1 is 129.39 degrees, and then A1 is 1.67. So we're able to get first gamma 1 and then alpha 1 and then A1. That was for our triangle 1 where gamma is obtuse. Okay, so for triangle 2, we'll say C work in T1. We found gamma 2, the acute angle is 50.61066 degrees. That's because when we set up law of sines and do inverse sine, we get the acute angle, which is gamma 2. Once we have two angles in any triangle, should be automatic to find alpha 2. Alpha 2 is 180 degrees. We'll move this over.
Okay, did you get it?
Okay, so Justin, let me check that. So students, while I check Justin's, go ahead and share in the chat what you're getting for alpha 2 and A2. Alpha 2 and A2. So a triangle 2, gamma 2 is the acute angle. Once you have gamma, you can find alpha. Once you have alpha, you can find A. So share your answers publicly. We'll bring it together.
Recording stopped.
Okay, Justin, let me check. Justin, I'm not receiving any email from you.
No, it says sent on my end. Okay, one sec. Sorry about this.
So keep working on that. So students, go ahead and share publicly what you're getting. Okay, I see answers coming in. Let's go ahead and resume here.
Recording in progress.
Okay. Okay, Justin, what you shared with me is not the exam file. We're gonna have to discuss after class because we need to continue with the lesson.
That's
But-
fine. That's fine. Sorry about that. For some reason, it's not going through it. On my end, it says I sent it, so, but
Yeah,
I'll
but
keep working.
I do need to have the timestamp, so I
Yeah.
keep working on that. Or else I wouldn't be able to accept the submission. Okay, so students, let's continue and with triangle 2, let's share right here. Okay, so I saw that we got alpha 2. Remember, we take 180 degrees minus 38 degrees minus 50.61066 degrees. So our alpha 2 comes out to be 91.38934 degrees. Notice that if we're going to use alpha 2 to find the next variable, we want to take it out to at least 5 places. So our final answers do not have rounding difference. Okay, and then we set up our sine of beta over b is equal to sine of alpha over a2. And we can solve for a2 by setting the diagonal products equal to each other. Isolate a2. A2 comes out to be 7.63. So the problems when you have two triangles, it becomes two questions because you have to solve each triangle. So for the first triangle, we got gamma 1, alpha 1, and a1. And then second triangle, we have gamma 2, alpha 2, and a2. So for our second triangle, gamma 2 is 50.61 degrees. Our alpha 2 is 91.39 degrees, and then A2 is 7.63. Okay, remember we learned that check step. So for triangle 1, looking at the angles from smallest to largest, they run, we have beta, and then, or actually it goes alpha 1, and then beta, and then our gamma 1 is our largest angle. Therefore, in triangle 1, A should be the shortest, and then B, and then C. So let's check. A is the shortest, and then B, and then C. So check. Triangle 2. In triangle 2, our smallest angle is, let's see, beta, and then we have gamma 2, and then we have alpha 2. Therefore, the side should go from B should be the shortest, then C, then A. So B is the shortest length, and then C, and then A. 4.7, 5.9, 7.63. That checks out. Okay, so students, take a look at what we did in solving the two triangles. And let's see, do we have any questions in solving T1 and T2?
I had a question about I don't know how to set up the T2 because the first triangle that we drew, I think it's a little bit higher up. It shows both of the triangles in one triangle, and I didn't understand how the dimensions translated to T2.
Okay, yes, I'll address that. But since I just received a submission here,
because it wouldn't let me convert it to a PDF, so I had to keep it in images. I had to lower it down to like 125 megabytes.
Yeah, so
So they're super grainy.
at this point, I'm going to, I did receive the picture, so I will grade from what you have submitted.
Okay, you
Yeah.
can make it out though, because it's super grainy on my end.
Yes, I haven't been able to review the images.
Can we just talk after class?
Yeah, we can
Okay.
check. Okay, students. So going back who was asking the question about triangle 2?
Me, Stephanie.
Stephanie. Okay. Yeah, let's go back up here to the first image. Okay. So this one is triangle 1. And in triangle 1, we can see across from 5.9 gamma, gamma 1 is an obtuse angle. Okay, so that's triangle 1. And then here, this is triangle 2. In triangle 2, gamma 2 is going to be an acute angle. Okay, so those are the two triangles formed with the info given, the side-side angle. Okay, so now when we're going to the setup for triangle 2, gamma 2 is the acute angle. We found that using inverse sine. Then from there, we got alpha 2. And from there, we got A2. So, Stephanie, does that clarify? Which part of the setup did you have questions on?
I think I just had questions about T2. How do we know that the left side is 5.9? Because I thought it was going to equal. I think I was just confused by the first image,
Okay,
but they're
Yeah.
both together.
let's do it like this. Yeah, so do you see that for both of them? We'll use orange here. This side is 5.9. C is 5.9. The side across from gamma is always 5.9, is given here as 5.9.
Okay, so T2 is on the entire triangle, and then T1 is just the triangle on the left.
Yeah, so let me show us again, Stephanie. So right here, look at the screen. This is T1. You see on top there?
Yeah.
That's T1. Okay, let me go back. And then look at the screen. This is T2.
Got it. Okay. I think I was just confused by the other green line. I thought that the two green lines represented T2.
Oh, no, yeah. The two green lines just show that the side across from the given angle can be to the left of the height or to the right of the height. So
Got
that,
it.
yeah,
Okay.
triangle 1 is drawn T1, and then triangle 2 is T2.
Okay. Thank you.
You're welcome.
Thank you, Professor. I was confused too.
Great. Yes, good to clarify. And so that line, that green line, side across from given angle, if it's less than the other side given, but greater than the height, then it has two positions it can go in. It can go to the left of the height or to the right of the height. And that's why it does form these two triangles. Okay. So take a screenshot here of the work that we had to solve for triangle 1 and triangle 2. Okay, and now let's go ahead and move forward and look at some of these application problems. We'll look at air navigation and marine navigation. Okay. Okay, so for air navigation, we have a key term here called bearing. In this problem, they asked us to find the bearing for the following angles. So let's draw in here in our grids. When we are putting the angles in standard position, we start at 3 o'clock. However, when we are drawing in bearings, we start at the north line. So starting from a ray pointing due north. When you see the term bearing, we're starting north. Okay, and we're moving clockwise. So angles in standard position start at the east line and travel counterclockwise, but bearings are going to start at the north line and travel clockwise. So let's put directions here to remind us. This is north, east, south, west. Never eat sour wheat. So north, east, southwest. Okay. Bearings, we start at the north line and travel clockwise. So we'll highlight that. Clockwise direction starting from a ray pointing due north. 100 degrees is 10 degrees past 90 degrees. So we land here. 225 degrees, that's going to be 90 plus 90 plus 45. We land here. 65 degrees, that is 25 degrees shy of a right angle. We're here. Okay. For marine navigation, they give us the north-south or east-west direction. So for marine navigation, if we're going northeast, let's highlight this is northeast. We start the north-south line and then go towards the east-west line. So north 60 degrees east, that means we start north and travel 60 degrees towards the east direction, right there. The next one, if we're going southeast, I'm going to highlight here southeast. Oops. East is this direction. Southeast. So we always start in the north-south lines and then travel towards east or west. So for southeast, we start the south line and travel 30 degrees towards the east line. Okay, and then southwest. We start at the south line and we travel 45 degrees towards the west. So start south, travel 45 degrees towards the west line. Okay, so when we see the key term bearing, we're going to start north and naturally go clockwise. So start at 12 o'clock and travel clockwise. If they give us the north, south, east, west directions, then we start at the north, south line, travel towards the east, west line. Okay, so with the time we have remaining, we'll probably be able to get through one word problem and then we'll save these last two for our discussion next week. So let's start this word problem. For the word problems, the key is setting up the triangle. From there, I have confidence that we can solve the triangle. Okay, so it says, during an important NATO exercise, an F-14 Tomcat left the carrier on a course with bearing 34 degrees and flew 400 miles. Okay, so let's draw that in. Bearing 34 degrees and flew 400 miles. So bearing means that we're going to start in the north line and we're going 34 degrees clockwise. So this is going to be the starting, the green star. From the north line, we've traveled 34 degrees clockwise. And that first leg is 400 miles. Then the F-14 flew for some distance on a course bearing 162 degrees. So we start at the north line and bearing means that we're traveling clockwise. So bearing of 162 degrees. 162 degrees is 18 degrees shy of a straight line. So we are going to be about here. Okay. So this is a bearing of 162 degrees. Okay. Travel in that direction. And then finally, the third leg, we're flying back to starting point, course bearing 308 degrees. So they gave us the bearings for all three legs. We have bearing of 34 degrees, then bearing of 162 degrees, and now bearing of 308 degrees. So 308 degrees is 52 degrees shy of one full rotation. So we know that we've traveled all the way down here so that, let's see, this should be north. Okay, so that means going all the no, we should draw it this way. From the north line, this is 308 degrees. Okay, so that's the info given to us. We have three legs of the course and it forms a triangle. When you have an oblique triangle, we need to have three pieces of information in order to solve. So let's draw a replica of the triangle here. Okay. So since this is supposed to be 308, I'm gonna elongate this to make it drawn to scale a little bit more. .308 Okay. So the information given is the first leg we went 400 miles. So this is the starting point in green. Second leg, they didn't tell us the distance. And then third leg, they want us to find what distance did the plane fly on the final leg of the journey. So that's what we're trying to find. We'll call that D. The distance the plane flew on the final leg of the journey. Okay. So in order to solve for D, we need more information. We so far only have one side. We need more information to solve our oblique triangle. So let's look at the bearings to help us. Okay, so the first thing I'm seeing from geometry is we know that when parallel lines are cut by a transversal, alternate interior angles are congruent. So that means these are alternate interior. These ones are also alternate interior. Parallel lines, so the north-south lines are parallel. Parallel lines cut by a transversal, alternate interior angles are congruent. So congruent and then congruent. Okay. So that means the pink ones are 34 degrees. And that blue one, 180 minus 162. That blue angle is 18 degrees. So the blue ones are 18 degrees. Okay, so that means we have one angle, 34 plus 18. So 34 plus 18 is 52 degrees. Okay, so far we have one angle, one side. We need one more angle. Jacob, how can we find this missing angle here? We'll call this one alpha. Jacob, please unmute.
Sorry. So we can add 18 and 308 together and then subtract that from 360.
Very good. One full revolution is 360. So if you do 360 minus 308 minus 18, that's going to leave us with alpha, which is 34 degrees. Okay, so with the bearings for each leg and the distance for the first leg, we're able to draw an oblique triangle with 2 angles and 1 side. So this is called angle, angle, side. And with angle, angle, side, we can use the law of sines to solve. So law of sines is you take sine of an angle divided by its opposite side is equal to sine of any other angle in the triangle divided by its opposite side. The most difficult part for these problems is setting up your triangle. Once you've set up your triangle, it becomes an easy algebra equation. And now we can set the diagonal products equal to each other. We have d sine of 34 degrees is equal to 400 sine of 52 degrees. Okay, so students, go ahead and isolate d. We want to make sure that our calculator is in degree mode, and then share in the public chat what you're getting for the distance. And when you're looking at our picture, 400 miles is across from 34 degrees. D is across from 52 degrees. So your D value should be greater than 400 miles. The plane flew a further distance in that final leg than in the first leg. And we can see that from the info given. Okay, share your D value, and it says round to the nearest hundredth of a mile. We'll just make a note here. Our calculator is in degree mode. Okay, students, I see some agreement. Yes, so the distance for that last leg, D, should be 563.68, and distance is measured in miles. Okay, so take a look at this word problem, see if you have any questions before we close the session. Okay, so looks like we'll be wrapping up 5.1 next week. So as we prep for the last 2 weeks of the semester, the chapter 5 and 6 lecture note templates are already posted. Download and print those out, and then start reading and working ahead. So we've already completed chapter 4. Work on those homework assignments. And looking at our calendar, we have a couple quizzes remaining, exam 3, and then the final exam. Okay, we've been saying if the whole semester is pi, now we've completed 4 weeks out of 6, so 2 pi over 3. Next week we'll be at 5 pi over 6. Following week we would have finished the entire 4-unit trig course. So keep working hard. Justin, stay. Class is now dismissed. Thank you for participating. I will see you next week. Have a good one.
Professor,
Yes.
will you be emailing us what chapter or what sections will be on the quiz next week?
Let's see when the quiz date is.
I think it's Tuesday.
Oh, so since it's Tuesday, we'll announce it on Monday.
Okay. Thank you.
You're welcome.